Now let's get into our very first problem. Now I would like for you guys to first read the problem statement in the description before listening to the rest of the lecture so that you get a better understanding of what it's being asked. Okay, so basically you have a sender and a receiver, and PC1 is going to be the sender and PC4 is going to be the receiver, and you have been asked to draw frames for each of the hop. Remember that frames are the data units for data link layer, and data link layer does hop-to-hop delivery, and frames have in them port addresses, IP addresses, and MAC addresses. And this is why I went over all this before getting into this problem. Okay, so in this problem, you guys have been basically asked to draw the frames from hop-to-hop delivery. All right, so we know how to kind of identify the hops that's going to be taken. We basically have idea on all the addressing and everything. So let's just get into it. Okay, so reading the problem statement, it's been said that the alphabet's going to be the IP address. Okay, so each of the device, remember guys, as I previously said, every device in the network will have an IP address that's going to identify the host or the device, and a MAC address that's going to identify the physical interface through which the data is going to come and go from in that device. And also for the applications running within that device, it will have port addresses. Okay, so in this particular scenario, the IP address has been marked by capital letters. Okay, so this is just for simplicity. Normally IP addresses would look something like 192.168.1.5, something that you guys use as a proxy in labs. That is what typically an IP address would look like, but over here we're just going to be representing IP addresses through capital letter alphabets. Okay, and then the MAC addresses are numbers. So you see this portion over here, this is the MAC address. So you guys basically have an IP address and MAC address assigned to each of the devices and also these router interfaces. So remember, every router interface will have a separate IP address and MAC address. Okay, so this interface over here has an IP and MAC, and this interface over here also has a separate IP and MAC address. Okay, so all right, let's get into it. The first hop, remember we just saw it a while back. The first hop is going to be, all right, let's first look at the path. If PC1 wants to send some data to PC4, the shortest path is going to be from here to here. Okay, all right, so now that's done. We are going to be looking into our hops. All right, so at first PC1's going to send some data to this interface of the router, right? This D interface of router 5. Okay, so the first hop is going to be this. All right, so I'm just going to write 1. So for the first hop, we are going to have to draw the frame. Okay, so since port addresses are not explicitly mentioned over here, so within this data that's written over here, port address is going to be embedded, but we are not going to be concerning ourselves with that. Since IP addresses are given, we are going to be writing the sender IP, which is A, and then the destination IP, which is M, right? Remember that the sender IP and the receiver IP is not going to be changing throughout these jumps because your sender and receiver device is not changing. Suppose you want to send some data to your friend. So you are going to be the sender and your friend's going to be the receiver. And this fact is not going to change throughout the communication. Okay, what's changing is the jump. The data while being sent is being sent through different jumps, but you and your friend, the communication is going to be happening between you two, and that fact is not changing. So for the first jump or for the first hop, the sender MAC is basically 11 and the destination MAC is going to be 13 because this is where the data is going to come to. Okay, so the destination MAC 13, and this is the first frame for the first hop. Okay, all right, and then the next hop's going to be from this E interface of router 5 to the F interface of router 4. Okay, so all right, I'm just going to be clearing out everything. All right, so the next jump is going to be from this E interface to this F interface. Okay, remember guys, the data is going to move from the D interface to this E interface, but we are not going to be calling this hop-to-hop delivery because these are two interfaces of the same device. Since it's within the same device, this is not going to be a hop-to-hop delivery. Okay, so the second hop is going to be from here to here. Okay, so for the second hop, the frame's going to look something like this. Your sender IP is going to be A. Your sender receiver IP is going to be M because the sender and the receiver device have not changed. Your sender MAC is now going to be 21, this one over here, and your receiver MAC is going to be 22, this one over here. Okay, and when that's done, the data is going to flow from router 5 to router 4. Okay, and then for the third jump, that's going to be from this G interface of router 4 to this H interface of router 7. Okay, remember the movement from this F interface to G interface is not going to be considered a hop-to-hop delivery. Okay, so once again, the sender IP and the receiver IP does not change. The sender is still A and the receiver is still M. Okay, the sender MAC now is going to be 31 and the receiver MAC now is going to be 32, right? And this is going to be our third frame for the third hop-to-hop delivery, and the data is going to flow from router 4 to router 7. All right, now for the fourth hop-to-hop delivery, the data is going to flow from this router 7 to PC4, and it's going to go from this interface N of router 7 to this PC4. The sender and the receiver IP does not change. The sender MAC now going to be 41 and the receiver MAC now going to be 42. And when that's done, the data flows from router 7 to PC4. All right, so then you have all the 4 different frames for the hop-to-hop delivery from the sender to the receiver. Okay. All right, let's look at a similar problem. The scenario hasn't changed. The problem statement is more or less the same, but now the sender device is PC1 and the receiver device is this email server. Okay, you have one additional information in this scenario, and that's the port number. You didn't have port numbers in the last problem that we just did, so everything else stays the same. You basically have uppercase letters representing the IP addresses and the digits are numbers representing the MAC addresses, and you have IP and MAC assigned to every device and the router interfaces. Okay, additionally, lowercase alphabets or small alphabets going to be our port numbers. Okay, and this is our process identifier. So suppose PC1, you are using PC1 and you're using email service and you're also using web browser. Okay, so the port number for email is A and the port number for web is C. All right, and the port number for email on the receiver is K. Okay, so these are basically port numbers. And in the problem, it's mentioned that the sender is trying to send an email to the email server. Okay, so obviously our process is going to be this email. Okay, we have nothing to do with this web browser. Okay, we have been asked to draw the frames for the emailing process. Okay, so we will be restricting ourselves to that. All right, everything else kind of stays the same. So since PC1 is trying to send some data to the email server, let's first look at what path's going to be taken, the shortest path. So the data is going to go from PC1 to this router 5, and then from router 5 to router 4, and then from router 4 to router 7, and then from router 7 to the email server. Okay, this is going to be the path. So we are going to be drawing the frames for each of the jumps that's going to be taken in order to traverse this path. The first jump is going to be from PC1 to this router interface, right? It's going to go from PC1 to the D interface of router 5, okay? So the process, the sender process is A because we are dealing with email, and the destination process is going to be K. Okay, and once again, this is never going to change because since you are doing email, so this fact has not changed. What's changing is just basically the hops that's being taken when you're trying to send the data. And the sender IP is going to be A. This still hasn't changed. The destination IP is going to be M. Once again, this hasn't changed. And for the first hop, and this is the first frame, by the way, guys, this is the first frame, okay? So for the first hop, the data is going from this sender to this interface of the router. So the MAC address for this sender is 11, and the MAC address for this interface is 13. All right, so the destination MAC address is going to be 13, and this is the first frame for the first hop. And when all this information has been filled out, the data is going to go from PC1 to this router 5. Okay. Now for the second frame, just going to erase some stuff over here. Okay. So for the second frame, the hop's going to be from this E interface of router 5 to this F interface of router 4, right? It's going to go from here to here. Okay, so the sender port is still going to be A because it's still data for the email, all right, and no other processes. And the destination process is going to be K. The sender IP is going to be A. This doesn't change. Destination IP is going to be M. For the sender MAC, since the jump is being taken from this physical interface to this physical interface, so the sender MAC is going to be 21, and oops, should have marked here, and the destination MAC is going to be 22. Right, and this is the second frame, okay? And then when that's done, data goes from router 5 to router 4. Okay, for the third frame, the jump is going to be taken from this G interface of router 4 to this H interface of router 7. So it's going to go from this interface to H interface of router 7. All right, so once again, port sender and destination port doesn't change, IP doesn't change, but the MAC is going to be now 31 and 32 for the third hop top delivery, okay? And when that's done, data is going to go from router 4 to router 7. Now for the fourth, and for the fourth frame, the data is going to go from this N interface of router 7 to the email server. So the hop is going to be from N to M, and once again the port numbers won't change, the IPs won't change, but now the MAC's going to be, sender MAC's going to be 41, the MAC of this N interface, and destination MAC's going to be 42. Okay, so when that's done, data is going to go from router 7 to email server. Okay, so the last problem we did and this problem is more or less the same. Just in this problem, you had some additional information that you dealt with. Okay, remember that a frame has all of this information. It has port number, MAC addresses, and IP addresses. So let's do a very rudimentary problem. We already did much more complicated ones. So in the same scenario now, we are going to be sending data within the same network. And since it's within the same network, you do not need to cross a router. The routers are the devices that create separate networks. If you don't really have a router, it's just have only one network, okay? So once again, you have some IP addresses assigned by alphabets and MAC addresses assigned by numbers, okay? And now your sender is PC1 and your receiver is this PC2. Now the sender and receiver are within the same network, okay? So if that's the case, then it can just directly go from the sender to the receiver. So your sender IP is going to be A, your destination IP is going to be D, your sender MAC is going to be 11, and your destination MAC is going to be 14. So once that's done, the data directly goes from the sender to the receiver. Okay, with just one jump. You don't really need to cross a router when you're sending data within the same network. So let's just quickly review what we just learned. So a sender device can have multiple processes running. So here you have processes A, B, and C running. Hang on, let me get the pointer instead. So you have processes A, B, and C running within the sender A, and receiver P has processes J and K running, okay? So normally port addresses would be numbers like 80 or 1, 2, 3, 4, so on, okay? But over here, port addresses have been represented using small letters. And this A for the sender is the IP address. Normally IP addresses would typically look something like 168.13.1.0, so on. All right, so basically the idea you need to keep over here is when data comes to transport layer will add port address, the sender port and the receiver port. So in this particular scenario, the process A is trying to communicate to process J of the receiver, okay? So this is something the transport layer is going to add the port number, and then the transport layer is going to send the segment to the network layer, and the network layer is going to be adding the IP address that's going to tell you where exactly is this process running. So since sender is A, so it's going to add the IP address of A, and then since the receiver is P, it's going to send the destination IP as P. And then the network layer is going to be sending this packet to the data link layer, and data link layer is going to be adding the MAC address. Now, you see this H2, this is the header. In this header, MAC address is one of the information that's going to be added. And when that's done, data is just going to be sent through hops. And throughout this hop, this MAC address is only going to change. this IP and port address is not going to change. So thank you guys, that's basically it. I hope you guys were able to understand the problems. If you have any confusion regarding any of the problems, we will be having a live problem solving session, so make sure to attend that session if you have any problems. And hopefully we'll also be doing some exercises on this to get your concepts cleared out. Okay, so thank you so much guys for watching this video. So see you guys later. Till next time. Bye.